Okay, so we're now beginning with the second part of our question. Now if you remember, we're solving not only the moment of inertia of the figure upon the horizontal centroidal axis, which is our x, we're also going to solve its moment of inertia upon the vertical centroidal axis, which is our z. Our first and second steps, since they only dealt with separating our figure into recognizable parts, our first and second step will be exactly the same. Alright, so as you can see, our first and second parts are identical to our first part. For our third step, we'll now be calculating the position of our centroids for each individual shape upon the z-axis. So, where are we going to measure its position? Of course, that will be reliant on our x-axis. So over here, we know that we've already solved when it's coming for the x-axis, when our figure is based upon the horizontal centroidal axis. Well, now we're going to base it on the z. So instead of finding its position from our horizontal axis going up to find out where exactly these purple crosses are, we are instead going to come from the left-hand side towards our position. So we'll be shifting our perspective a bit. So instead of going from down to up, we'll be going from left to right till we find our purple crosses. For the first and sixth shape, their centers are the same. So if we come from the left-hand side, going to the right, we can see that they're both around the same position away from the left side. So since they're at the center, and since we know the length of the sixth shape, simply by dividing 1 and 1/2 by 2 can get us our position, which is 0.75 inches each. Okay, so to figure out the positions of our 2 to 5th shape, let's zoom in this portion so we can take a better look. Okay, let's first start with our squares, which is our second and third shape. This is our focus points. The first thing that we know is that this entire length is 1 and 1/2. So if we're trying to solve for the third shape, which is our square, we can simply divide this by 2 so we can get the exact half of this figure. So here we got the exact length of this half. 1/2 of the figure, which is 0.75 inches. What about this part? Since we know that this entire vertical bar is 0.064 inches, by simply dividing that by 2, we can get exactly half of it. So the answer we got is 0.032 inches. Now again, to remind, what are we finding here? We're finding for this centroid position, which is technically this distance away. So by finding what this distance is, we can figure out what our position is from the vertical axis. Now, to find out for our final missing value, which is this one, we are given the lengths of our sides, which is 1/8 inches. So since this is exactly at the center, we can then say that by simply dividing 1/8 by 2, we can get this answer. Alright, so now that we have all our missing values, we can simply subtract 0.75 by the sum of these two lengths, which is 0.0625 plus 0.032. And our position will be 0.6555 inches. So now let's proceed with our second shape, which is this second square. Alright? So unlike the previous part, where both of them would be of the same position, here, this is slightly longer away. We already know what our lengths are. So over here, exactly at half, it's 0.75. So we already have this length. Now what else is missing? We're missing this and this. Well, this one as we already figured out earlier, it's just 0.064 divided by 2, which is 0.032 inches. And this one, we already know that its length is 1 by 8. Simply being at the center will mean that by dividing 1 by 8 over 2, we can get this length. So altogether, by adding all of these lengths, we would get our position for shape number 2, which is 0.8445 inches. Okay, so now let's proceed to our quarter circles. Okay, so here we're going to focus on our fifth shape, which is this quarter circle with its center assumed to be over here. Alright, so now for calculating its position, we already know that this is 0.75 inches, and we know that this is 0.032 inches. However, we do not know what this unknown value is. In order for us to know the exact position of our centroid. So how do we do this? Well, we already know what this length is, which is 1 by 8 inches. However, we do not know what this length is, precisely this length. So what do we do to find that out? Well, there is a specific formula for finding out the centroid of a quarter circle, as we discussed back in the first part. Now, what was it? It was 4r over 3 pi. This 4r over 3 pi is precisely what this length is. By finding out what 4r 3 pi is, just by substituting 1 over 8 over to this formula, will get you this missing length. Now, once you find this missing length, it's all about subtracting 1 over 8 minus this length that we found out by substituting 4r over 3 pi will get us this missing unknown value. Well, let's sub it in so it's much more easier to see. We get 0.0531 inches, which is this orange length. Now, what we needed was this missing length. So what did we do? We subtracted 1 over 8 minus this orange length in order to get this missing yellow length, which is 0.0719 inches. Well, now that we have this, we can simply subtract the sum of 0.0719 and 0.032 from 0.75 inches, which is 0.6461 inches. Okay, now let's solve for our final shape. So over here at the center, we are already given the length of 0.75, which we solved earlier, exactly at half. We already have this length, 0.032. And now we're finding for the missing yellow length yet again, to finally complete our position from the vertical axis all the way to our centroid position of our last quarter circle. Well, we're already given the length, 1 over 8 inches, and we can figure out what this length is from this formula, which we did earlier. So now we got our answer, which is 0.0531 inches for this side. So, obviously, by subtracting 0.0531 inches from 1 over 8 inches, we can figure out our final missing length, which is 0.0719 inches. Now by simply adding 0.75, 0.032 inches, and 0.0719 inches, we can determine what our position is, which is 0.8539 inches. So now for our fourth step, we simply multiply each corresponding shape's area and its x position. So now we've solved for each corresponding axis. We also, of course, solve for its total, which is 0.1339 inches cubed. Okay, so now that we got the sum of AX and our total area, we can finally figure out what is our centroidal position for our entire figure. But this time, we're basing it around from our vertical axis. So we're going to utilize this formula, which is basically our sum of AX divided over our total area. Now that we plugged in our values, we can see that our inches squared, the denominator will cancel, along with our exponent, which will only leave us with inches, which is what we want. Our answer is 0.7501 inches. So now coming back here, our fifth step is simply squaring our x positions. Accordingly, these are its values. Now let's move on to our sixth step. Our sixth step, accordingly, is just our corresponding area for each shape with its x squared value. And here are our calculated values. Now, of course, for our sixth step as well, we're gonna calculate for its summation. Okay, so for our last and final step, we're gonna calculate the moment of inertia for each individual shape. Now, similar to our first part, we calculated it based on their specific formulas. So let's have these formulas out there. Alright, so here are our formulas. Now, as you can see, for rectangles, we follow base height to the power of 3 divided by 12. For squares, we follow 8 to the power of 4 divided by 12. For quarter circles, we have pi r4 all over 16. You can go back to the first part of this video to explain why these formulas come into play. Well, there's one note that I need you to be attentive of. Whichever side is parallel to the axis that you're referring to. So for here, for example, at the first part, we're referring to the horizontal x-axis. Hence, since this width of this figure is parallel to our x-axis, that is our base, and the other side is our h. That is because we're basing it upon the x-axis. Now what if, like our second part of this problem, we're basing it around a different axis, the vertical axis this time, which is our z? You will no longer be following this base and height. What's going to happen is that we're going to change our perspective to be coming from the vertical side. So instead of down to up, we're going left to right. If you're basing it upon the vertical axis, this is now your base, since it's parallel to the vertical axis, and the other side is our height. And these are the values that you're going to substitute in its specific formula. So now that we know which values to input in our formula, let's solve to get our moment of inertia for each shape. So here are our values. Now, of course, even for this one, let's calculate the summation. Our total summation is therefore 0.018 inches to the power of 4. So now, using our parallel axis theorem, but instead now we're going to base it upon the z-axis. So simply plugging in the values that we already have, we can solve for this formula. So now our value is 0.1184 inches to the power of 4. So now that we got all of our necessary variables, we can finally calculate for our moment of inertia for the entire figure based upon our vertical axis. So now, utilizing our moment of inertia formula, we already have our variables, which is the parallel axis theorem upon the z-axis, and our summation of ax squared. Now, plugging in the values, we can get our answer. So the answer that we got is 0.018 inches to the power of 4. And that is your final answer.